Okay, so we're going to pick up right where we left off. And again, this section is really all about knowing those sum and difference formulas. And if you know the formulas, it's really just substitution. Here, the tangent of a sum, the formula reads tangent u plus tangent v, all divided by 1 minus tangent u tangent v. Alright, so that's the formula we'll be using. And if I expand this notation right here using the formula, it's going to read tangent theta plus tangent 3 pi, all divided by 1 minus tangent theta times the tangent 3 pi. This expansion becomes relatively easy to simplify because tangent 3 pi is the same as the tangent of pi. And we know if you're thinking y over x, that's 0 over 1 if you're thinking on the unit circle, or 0 over negative 1. So this right here is a total of 0. This right here is a total of 0. And in fact, 0 times tangent theta, this whole piece is 0. So this function is going to read tangent theta plus 0, all divided by 1, but really just the easy way to simplify and write that is just tangent theta. There's nothing more to it. All right, so our last problem of the day is, again, just using the sine and the sum of a sine, the sine of a sum, and the sine of a difference. Both of those formulas. Here we're going to do a little bit of solving. So what we are going to do is we're going to expand this part first. So I won't write the formulas for this one because we've seen them before. This would read sine x cosine pi over 4 plus cosine x sine pi over 4. And here, I'll switch colors, and now I'm going to expand this. Now it's a slightly different formula for the, so I'm copying over this plus sign, and now I'm expanding, and it's sine x cosine pi over 4 minus cosine x sine pi over 4. And I know all of this is equal to negative 1. So I've got to solve for x, and now that I've expanded, I should be able to solve using some of our techniques from last section. And what I do know is sine x cosine pi over 4. So what I'm looking at right here, this and this are like terms. And in fact, right here, this cosine x sine pi over 4 and negative 1 cosine x sine pi over 4, I really don't have to, those are also like terms, but with the positive 1 and the negative 1 in front, those two add to 0. So I don't have to worry about those. What I do notice is I have those like terms right here. I can combine these, call it 2 sine x cosine pi over 4. So I've simplified quite a bit. I still know it's all equal to negative 1, and I haven't even done an operation to both sides. And I'm still not going to do an operation to both sides because I know the cosine of pi over 4 right off my unit circle. I know that is radical 2 over 2. Normally, you don't write the radical 2 over 2 here at the end. What I'm going to do is I'm going to write that radical 2 over 2 right in front. Radical 2 over 2 sine x equals negative 1. If you notice, the 2's are going to cancel, and you're left with radical 2 sine x equals negative 1. Divide both sides by by radical 2. And we are now looking for where sine x is equal to negative 1 over radical 2. Now it's strange, you don't usually see radicals in the denominator. What you need to do, if you recognize we can rationalize this portion of the fraction, multiply by radical 2 over radical 2, and you could say sine x is equal to negative radical 2 over 2. Now you would realize that is right off the unit circle. Sine is negative in quadrants 3 and quadrants 4, so let's just look at the directions. The directions say we only need the answers between 0 and 2 pi. So that's in quadrants 3 and 4, so that would be x is is equal to 5 pi over 4 and 7 pi over 4. Those will be our final answers. This section is really about knowing the 6 sum and difference formulas, and if you know those 6 formulas, it's just plugging into the formula and going from there. I hope you find this easier than some of the proofs we were doing earlier in the chapter.